to the Oracle Autonomous Migration and Data Loading module. We will be covering several topics during this module. We will start by describing the options and considerations for migration to ADB. We will then cover migrating to ADB using Data Pump, followed by how to migrate or synchronize ADB with Golden Gate. Once data is migrated into ADB, Oracle Data Sync can be used for synchronization of ADB with source systems. In the last section, we will cover how to use DBMS Cloud for loading data into ADB. When you have completed this video, you will be able to describe the options and considerations for migrating to ADB. You will be able to articulate how to migrate to Autonomous Database with Data Pump and Golden Gate. Finally, you will be able to articulate how to load data to ADB with Data Sync and DBMS Cloud. Let's start with the migration options and considerations. The diagram above provides a high-level architectural diagram for different ways to load and maintain data in ADB. Data can be loaded directly to ADB through applications such as SQL Developer, which can read data files such as text and XLS, and load directly into tables in ADB. A more efficient and preferred method for loading data into ADB is to stage the data into Cloud Object Store, preferably Oracle's, but also supported are Amazon S3 and Azure Blob Storage. Any file type can be staged in Object Store. Once the data is in Object Store, Autonomous Database can access it directly. Tools can be used to facilitate the data movement between Object Store and the database, for example, IMP, DP, and for export, DMP files from other databases, or Parquet, JSON, .csv format, among others. Depending on the amount of data to be loaded, either of these strategies would work. A physical database can't simply be migrated to Autonomous Database because the database must be converted to a pluggable database, upgraded to the current version of the database, and encrypted. Any changes to Oracle shipped store procedures or views must be found and reverted. All uses of container database admin privileges must be removed. All legacy features that are not supported must be removed, such as legacy large objects. Data Pump must be used for migrating databases versions 10.1 and above to Autonomous Database, as it addresses the issues just mentioned. For online migrations, Golden Gate can be used to keep old and new databases in sync. More on this will be covered later in the module. When considering the extended set of methods that can be used for migration and loading, it's important to segregate the methods by functionality and limitations of use against Autonomous Database. The considerations are as follows. How large is the dataset to be imported? What is the input file format? Does the method support non-Oracle database sources? Does the method support using Oracle and/or third-party object store? Use the chart in this slide to go over the considerations to decide which method is the most appropriate for any specific Autonomous Database loading requirement. You can load data into ADB Cloud using Oracle database tools and Oracle and third-party data integration tools. You can load data from files local to your client computer or from files stored in cloud-based Object Store. The Oracle Autonomous Database has built-in functionality called DBMS Cloud, specifically designed so the database can move data back and forth with external sources through a secure and transparent process. DBMS Cloud allows data movement from the Object Store, data from any applications or data sources, export to text, .csv or JSON, output from third-party data integration tools. DBMS Cloud can also access data stored on object storage from other clouds, AWS, S3, and Azure Blob Storage. DBMS Cloud does not impose any volume limit, so it's preferred method to use. SQL Loader can be used for loading data located on local client file systems into Autonomous Database. There are limits around OS and client machines when using SQL Loader. Data Pump is the best way to migrate a full or part database into ADB, including databases from previous versions. Because Data Pump will perform the upgrade as part of the export-import process, this is the simplest way to get the ADB from any existing Oracle database implementation. SQL Developer provides a GUI front end for using Data Pump that can automate the whole export and import process from an existing database to ADB. SQL Developer also includes an import wizard that can be used to import data from several file types into ADB. A very common use of the wizard is the import Excel files into Autonomous Data Warehouse. Oracle Object Store is directly integrated into Autonomous Database and is the best option for staging data that will be consumed by Autonomous Database. Any file type can be stored in Object Store, including SQL Loader files, Excel, JSON, Parquet, and of course, dump files. Flat files stored on Object Store can also be used as Oracle Database external tables, so they can be queried directly from the database as part of a normal DML operation. Object Store is separate than storage allocated to the Autonomous Database for dataset object storage, such as tables and indexes. That storage is part of the Exadata system and is automatically allocated and managed. Users do not have direct access to that storage. One of the main considerations when loading and updating ADB is the network latency between the data source and the Autonomous Database. Many ways to measure this latency exist. One is the website cloudharmony.com, which provides many real-time metrics for connectivity between the client and Oracle Cloud services. It's important to run these tests when determining which Oracle Cloud Service location will provide the best connectivity. The Oracle Cloud Dashboard has an integrated tool that will provide real-time and historic latency information between your existing location and any specified Oracle data center. When planning for a migration, after performing network and data transfer analysis, the total data transfer time to ADB should be quantified to ensure operational continuity. The chart in this slide includes a sample of how long it would take to transfer data into Object Store for then loading into ADB. The numbers here are representative of a specific location. If the transfer and post-importing into the database will be long, and if it's important to keep the source and new ADB systems in sync, contingency plans such as using Oracle Golden Gate to synchronize the database could be integrated into the migration plan. Customers that have a large database may want to migrate to ADB, and/or customers that have slow connectivity to an Oracle data center can leverage the data transfer service available to Object Store customers. This allows customers to ship their data on hard drives to Oracle Cloud Services, where they will be loaded into Oracle Object Store. For transfer operations that could take days or weeks and risk being interrupted, this provides a safe and multi-use movement method. When migrating data to Autonomous Database, table statistics are gathered automatically during direct path load operations. If direct path load operations are not used, such as with SQL Developer loads, the user can gather statistics manually as needed. When migrating an existing database that uses optimizer and parallel hints, ADB will ignore those by default. Because ADB runs in a highly tuned Exadata environment, most database operations should run faster, or at least as well as database tuned with lots of hints to perform faster. Should hints be required for some reason, they can be explicitly re-enabled. Autonomous Database uses hybrid columnar compression for all tables by default. This gives the best compression ratio and optimal performance for direct path load operations like the loads done using DBMS Cloud Package. If you perform DML operations like update and merge on your tables, these may cause the compression ratio for the affected rows to decrease, leading to larger table sizes. These operations may also perform slower compared to some of the operations on an uncompressed table. For best compression ratio and optimal performance, Oracle recommends using bulk operations like direct path loads and create table select statements. But if your workload requires frequent DML operations like update and merge on large parts of a table, you can create those tables as uncompressed tables to achieve better DML performance. Let's look at how to perform a migration using DataPump. DataPump XPDB and ImpDP can be used for database versions 10.1 and above as source databases and will perform the upgrade steps necessary to convert the database from older versions to the current Autonomous Database version. DataPump Import lets you import data from DataPump files residing on the Oracle Cloud Infrastructure Object Store, Oracle Cloud Infrastructure Object Store Classic, and AWS S3. You can save your data to your Cloud Object Store and use Oracle DataPump to load data to the Autonomous Database. Oracle DataPump offers very fast bulk data and metadata movement between Oracle databases and Autonomous Database. This is the preferred way to move between an existing database implementation and an Autonomous Database. The primary mechanism that data pump uses is data file copying, but will also leverage direct path, external tables, or network link imports. Oracle Data Pump Export provides several export modes. Oracle recommends using the schema mode for migrating to Autonomous Database. You can list the schemas you want to export by using the schema parameter. For a faster migration, export your schemas into multiple data pump files and use parallelism. You can specify the dump file name format you want to use with the dump file parameter. Set the parallel parameter to at least the number of CPUs you have in your Autonomous Database. The exclude data_options parameters ensure that the object types not required in Autonomous Database are not exported and table partitions are grouped together so that they can be imported faster during the import to Autonomous Database. In this example, you see under the exclude and data_options the recommended objects that should not be exported as they are either not supported or not recommended for Autonomous Database. To use data pump from ADB, a credential identifying the object storage bucket to use must be defined with the dbms_cloud.create_credential function. This will allow ADB to access objects that are stored in the object store, including dump files. To export an existing database to prepare for import into ADB, use the xtp command and add the exclude option for database functionality that is not recommended or supported in ADB. This will prevent errors during the import process. In this example, the exclude and data_options parameters ensure that the object types not required in Autonomous Database are not exported, and table partitions are grouped together so that they can be imported faster during the import to import your schemas and data. If you want to migrate your existing indexes, materialized views, and materialized view logs to Autonomous Database and manage them manually, you can remove these objects from the exclude list, which will export those objects types too. This is exporting the SH schema and is creating 16 parallel threads. To import and export a database into ADB, use the mtp command with the admin or user with permission to import and the connect string with the ADB wallet. This example shows importing using the defined credential and from a dump file in object store. In the previous export, we had created 16 parallel streams, so we will import with the same parallel parameter. The same exclude options are specified. For the best import performance, use the high database service for your import connection and set the parallel parameter to the number of CPUs in your Autonomous Database as shown in this example. If using data pump versions 12.2 or older, the credential parameter is not supported. If you're using an older version of data pump import, you need to define the default credential property for Autonomous Database and use the default credential keyword in the dump file parameter. An extra step is necessary in this case. The same process as before would be used to create the credential, but after the created credential needs to be made the default credential. This is done with the altered database property set default_credential statement as seen in this slide. In the mtb command, the keyword default_credential is specified before the location of the dump file in the dump file parameter. See the example in this slide. The log files for data pump import operations are stored in the directory data_pump_dir. This is the only directory you can specify for the data pump directory parameter. To access the log file, you need to move the log file to your cloud object storage using the procedure dbms cloud.put_object. This process is not automatic, and if the logs are not moved, you will receive a warning when running the mtb that the logs are not there. In this example, we're moving the log import.log to object store with the dbms cloud.put_object command. Migrations to ADB using Oracle Golden Gate. Good uses for using Golden Gate to replicate information to Autonomous Database include using Oracle Golden Gate on-premises to replicate data to Autonomous Database for real-time data warehousing, replicate on-premises data to the Autonomous Database to set up a staging environment for downstream ETL or real-time data warehousing. For operational reporting, replicate real-time data from multiple on-premises data sources and deliver to the Autonomous Database for creating reports. The Oracle Golden Gate Cloud Service can also be used to migrate data to the Autonomous Database. There are some limitations of using the Golden Gate replicate process with Autonomous Database. Currently, only non-integrated replicates are supported with Oracle Autonomous Database. For the best compression ratio in your target tables in Autonomous Database, Oracle recommends replicating changes, including updates and deletes, from your source system as inserts into staging tables and using in database batch operations to merge the changes into your target table. You can configure the Autonomous Database instance as a target database for Oracle Golden Gate on-premises. The source for replicating to Autonomous Databases can be Oracle Golden Gate on-premises release 12.3.0.1.2 and later. Those are certified with Oracle Autonomous Database for remote delivery using the non-integrated replicates only. However, any supported release of the Oracle Golden Gate for any supported database and operating system combination that can send trail data to Oracle Golden Gate for Oracle Database Release 12.3.0.1.2 and later can be used as a source system. Oracle Autonomous Database cannot be a source database, it can only ingest data. In other words, be a target database. The following data types are not supported while replicating data to Oracle Autonomous Database: long raw, XML type store as object relational, XML store as binary, B file, media, and spatial. To configure ADB for Golden Gate replication, use the pre-created ggAdmin user in ADB. ggAdmin has been granted the right set of privileges for Oracle Golden Gate on-premises replicate to work. By default, this user is locked. To unlock the ggAdmin user, connect to your Oracle Autonomous Database using the admin user using any SQL client tool. By default, this user is locked. To unlock the ggAdmin user, alter user ggAdmin identified by password account unlock command. For replication processes, a new target user must be created, which is different than the administration user just discussed. This user must be created and granted privileges to perform appropriate operations on the database. Once the user is created, connect to ADB as that user. To prepare the on-premise database for synchronization, the following steps must be followed. Log into your Oracle Golden Gate on-premises Oracle database. Create a new Oracle Golden Gate on-premises user. You can do that by the create user username identified by password. Grant DBA connect resource to the user just created. Create some tables for the process with the drop table and create table user source DWCS key, and create your extract using commands such as extract, user ID, xtrail, and table. To prepare on-premises databases for synchronization, these additional steps must be followed. Create your extract data pump with the extract command. Specify the RMT host. Select the appropriate tables and add your extracts. Adding extracts are done with the add extract, add extra trail, RM trail, specifying the DB logging, and specifying the tran data. Connect to your Oracle Golden Gate on-premises instance using an SSH and private key. Once you are connected to your Oracle Golden Gate on-premises instance, change user to Oracle and transfer the credential zip file that you downloaded for Oracle Autonomous Database. Contains a wallet connection information as described in previous modules. Edit the tnsnames.oro file in Oracle Golden Gate on-premises instance to include the connection details that is available in the tnsnames.oro file in your key directory, the directory where you unzip the credential file which you downloaded for Autonomous Database in the Connecting to Autonomous Database module. For Oracle Golden Gate replication, use adb_database_name low. To configure the wallet, create a SQLnet.oro file in the Oracle client location in the Oracle Golden Gate on-premises instance. Edit the SQLnet file as shown in the slide. Create a user alias and start GGSCI. Create a Golden Gate wallet and add the user ID alias to create the store. Configure Oracle Golden Gate Manager in Classic Replica to deliver to the Oracle Autonomous Database. If you're not already connected to your Oracle Golden Gate on-premises instance, connect using the SSH command. Once you are connected to your Oracle Golden Gate on-premises, change to the user Oracle From your Oracle Golden Gate on-premises instance, test the connection to your autonomous database using SQL+, and then create a new user for replication. Drop user, create user, alter user, and grant the user create resource, create view, create session, and create table. Log in as your new replication user, create the replication tables, connect the GGSCI, and configure Oracle Golden Gate Manager, and open the manager parameter file to edit it. That is done with the edit param manager command under GGSCI. Ensure that the manager parameter file has the following information: port number, access rules, purge old extracts, min keep files, auto restart, add the GG schema ggadmin to your globals file, and then stop and restart the manager. You're now ready to configure your replicate files, and as you can see in the slide here, these are the steps to configure the replicate file. At this point, the replication process should be running. Insert records into your source database and then ensure that the data is replicated into your Oracle Autonomous Database table using the stats repdwcs command. Now let's look at what's entailed in migrating using DataSync. Use DataSync to upload and manage data to Autonomous Database, commonly in conjunction with OAAC. You can load data files, CSV, and Excel, various relational sources, tables, views, SQL statements, OTBI, JDBC data sources, and Oracle Service Cloud. You can load to relational tables or datasets. Capable of incremental extract and loads, it supports several update strategies. Capable of deduping source data, and you can replicate and transform data when the target is Autonomous Database. DataSync supports transformations, ELT, surrogate key generation, foreign key lookups, etc. DataSync efficiently writes parallelizing data loads and using parallel streams for a target table. DataSync is capable of pre-post load processing, SQL and store procedures. DataSync job scheduling automates async data extraction from source, and DataSync can easily integrate with third-party scheduling systems. Supported DataSync sources are JDBC, MongoDB, Sybase, Hive, Salesforce.com, AWS, both Redshift and Postgres, MySQL, MS Access, Spark, and NetSuite. And supported targets include the Autonomous Database as well as others. Once DataSync is installed, to start using it, the steps to follow are: from the Project menu, click New and create a new project. In the Connections view, specify connection details for your data target and your data source if it's a database. In the Project view, specify loading options for your project. In the Jobs view, create a new job, then click Run Job. In the next few slides, we will show the screenshots of the process. From the Projects menu, click New and create a new project from Projects menu. Click New and create a new project. In the Connections view, specify connection details for your target and your data source if it's a database. For the URL, you will specify the service name for your database. Normally, this will be database_hi using the hi service. You will also need the path to the directory where you unzipped your wallet file. Please refer to the previous section where this was covered. Please note the example you see here on the screenshot. When done, click Test Connection to save the connection. From the main screen, you should see the connection set up in the previous slide, called Target. Highlight the connection and click on Project so you can create the objects and do the mapping. Use data from objects to import source table definitions. You can manually create the objects, but that takes longer and more prone to errors. Select the source connection target to connect to the database. Click on Search to bring a list of objects. If you get an error message, then you will need to go back to your connection and click on Test to make sure it's working. If it's then working, make sure your schema is in all uppercase letters. Select the Check Import definition, in this case for all three tables on the source database. Then click on Import. You should now see your source objects listed in the window. Now click on Data from Objects again so that you can add 3 flat files that are source. From the drop-down, choose File Source. For file location, specify your file location. For file name, this should already get populated from selecting the file. Logical name, this should already get populated from the file name. Do not select Delete Files upon successful load. Click on Next to continue to Import Options. Under Import Options, specify the information about the data in your source. Select Next. Since you are using an existing source, if you define one above, click Select an Existing. If you did not define one, then click Create New, followed by Select Next. Select how you want to map source columns to target columns. In this case, the mapping is by position. The column order will be the same in the source and the target databases. Repeat above steps to map every table in the source to tables in the target. You should end up with a source and target entry for each table you have on your target database. Once you have mapped all objects in the source table, in this case, File Inventory_Extract, and clicked on Targets tab, you will see a column that says Load Strategy. In this example, purge all the records before loading so you can reload. Double-click on the file that says Add New, Update Existing. In the pop-up, set the load strategy to Replace Data in Table and click OK. Repeat this process for every source object to import. Click on the Project Summary tab. A line showing each file loading into the correct target table should show. In this case, 3 tables. At the end of the record, the load strategy should be set to Replace Data in Table. Click on the Jobs button to create a job to run your project. Click on New to create a job. Fill in the parameters for your job. Pick your ADB database connections. Once your job completes, it should say how many loads were loaded and status of completed. At this point, your ADB database should be loaded with the information you selected from the source files. You can repeat this process for any source that DataSync supports. For data loading from files in the cloud, Autonomous Database provides a new PL/SQL package called DBMS_Cloud. The PL/SQL package DBMS_Cloud provides support for loading data files in the cloud to your tables in Autonomous Database. This package supports loading from files in the following cloud services: Oracle Cloud Infrastructure Object Storage, Oracle Cloud Infrastructure Object Storage Classic, Azure Blob Storage, and Amazon S3. For the fastest data loading experience, Oracle recommends uploading the source files to a cloud-based object store, such as Oracle Cloud Infrastructure Object Storage, before loading data into your Autonomous Database. Oracle provides support for loading files that are locally in your data center, but when using this method of data loading, you should factor in the transmission speeds across the internet, which may be significantly lower. Let's start by understanding how to create an object storage for Autonomous Database access. ADB uses authorization tokens to access the Oracle Cloud Infrastructure Object Storage. The first step is to generate the authorizations token for your cloud in Oracle Cloud Infrastructure. Then create a database credential in your Autonomous Database with this token. In Oracle Cloud Infrastructure, on the top right in the user icon, select User Settings. On the left, after selecting User Settings, select Authentication Tokens on the left. Select Generate Token. Slide 60. This will generate a token and be displayed. Once the token is generated, click Copy to copy to a clipboard, as you will need this to create the credentials and the token won't be displayed again. In a SQL connection to ADB and connected as admin, run the DBMS Cloud command using the authorization token just created as the password. In this example, we are creating a credential called obj_store_cred with the Oracle Cloud Infrastructure use of yasin.baskin@oracle.com. And for the password, we're using the token generated in the previous step. Object Store Cred is the credential name of the credential being created. You can specify any name you want. yasin.baskin@oracle.com is the Oracle Cloud Infrastructure username, which is the user who owns the object store, not the database user that you're connected to. Password contains the token we generated and copied to the clipboard. Once a credential is created, it can be used to access a file as an external table or to ingest data from the file into database tables. DBMS Cloud makes it easier to use external tables, and the organizational external needed in other versions of the Oracle database are not needed. To access the files in Object Store, use the DBMS Cloud copy data. In this case, we have a flat file in Object Store accessed by the credential we created in the previous step. This example maps the file on objects called channels.csv and maps it to an Oracle table called channels. When accessing a file in object storage, use the file_URI_list identifier to point to the file. There is a specific format the identifier needs to follow to make sure the file can be accessed. In the next few slides, we break down the components of the identifier. The HTTPS:// statement always starts with the keyword Swift Object Storage. Follow the data center region where the object store is. Next is the tenant name, which is the tenancy specified when logging into the Oracle Cloud, followed by the object store bucket that contains the file. And last, the actual name of the file in Object Store. The DBMS cloud.copy_data loads source files into an existing target table, handles compression, parallelism, logging automatically, and logs all loads in the table user_load_operations. Several parameters need to be defined to use this functionality. Let's see in more detail. You will need an existing table in the database. That is the table_name. You will need a defined credential name as discussed previously. You will need the file_URI_list as defined before. You will need the schema name that owns that table to be inserted into. The column list in the source files needs to be identified. The format of the source files needs to be specified. In this example, a CSV file is being loaded into channels table of the database. Note that not all parameters need to be defined. The DBMS Cloud Create External Tables creates an external table on objects stored and handles compression, parallelism, logging automatically. Several parameters need to be defined to use this functionality. Let's see this in more detail. The external table name defined in the database. You will need a defined credential name as discussed previously. You will need the file URI list as defined before. You will need to list the columns in the external table. This is the list of columns in the source files and the format of the source files. In this example, we're using a file called channels.csv residing in Object Store as an Oracle Database External Table, and the database external table is called channels_ext. Once a table is defined, it can be accessed like any other table in the database. Here we are running a select statement against a file on Object Store defined as an external table. All load operations are logged into the user load operations and DBA load operations tables in the database. For troubleshooting or reporting, these tables can be queried and they contain information such as how many records were rejected during a load. SQL Developer provides easy-to-use data loading wizards for loading data into Autonomous Database. Let's walk through an example of this functionality. As a reminder, SQL Developer is a free tool included with Autonomous Database. The SQL Developer Data Import Wizard enables you to import data from files into tables. To import data into a new table, right-click the Tables node in the Connections Navigator of SQL Developer and select Import Data. To import into an existing table, right-click the table and select Import Data. Beginning with the 18.1 release, you can use the wizard to load data from files in the Cloud Tables in Autonomous Database. For loading data from the cloud, Autonomous Database uses the PL/SQL package DBMS Cloud just discussed. In the Connections pane of SQL Developer, in the Tables tab of your connected ADB database, right-click and select Import Data. In the Source selection, select the Oracle Cloud Storage as the source type. Provide the file URI as described earlier, as defined in previous sections. In the Credential Selection list, you should have already defined the credential as discussed in the previous section. In the drop-down list, you will see the name of the credentials you created. Select the one you want to use. From this point on, the loading process is the same as any other loading process in SQL Developer. The main difference is the source file, the credential process used to load to an Autonomous Database. You can use Oracle SQL Loader to load data from local files in your client machine into Autonomous Database. Using SQL Loader may be suitable for loading small amounts of data as the load performance depends on the network bandwidth between your client and Autonomous Database. Again, for large amounts of data, Oracle recommends loading data from the Oracle Cloud Object Storage. SQL Loader will be the recommended path for loading from earlier releases such as 9.2 or 8i and so on. Generate a flat file and load using the recommended parameters from the above documentation. Oracle recommends using the following SQL Loader parameters for the best load performance. Read size, 100 megabytes. Bind size, 100 megabytes. Direct equals no. ADB gathers optimizer statistics for your tables during the load operations if you use the recommended parameters. If you do not use the recommended parameters, then you need to gather optimizer statistics manually. For loading multiple files at the same time, you can invoke the separate SQL Loader session for each file. Here is what we covered today. We started by describing the options and considerations for migrating to ADB. Then we articulated how to migrate to Autonomous Database with Data Pump and Golden Gate. Finally, we articulated how to load data to Autonomous Database with Data Sync and DBMS Cloud, followed by SQL Developer and SQL Loader.